Okay, let's look at another example of how to solve a rational inequality. In this scenario, I have 5 over x minus 3 has to be greater than 3 over x plus 1. So if this was an equal sign, you learn in Algebra 2 that you could cross multiply. Don't really want to do that here because you don't know what value this x is. If this could be a negative, then I have to switch my inequality. If this was a negative, I have to switch my inequality, and you don't really know what's going on with the inequalities. Now, we can treat it like an equal sign, do the equal sign, do the test. I've always done that, and it's always gotten me the right answer. But I had a former colleague that had a PhD in biochemistry say, no, you can't really technically do that. So we're going to do this the mathematically correct way of doing this. So what I'm going to do is I'm going to get the set equal to 0. So I can either subtract this and bring it over here, or take this and subtract over there. I'm used to having my 0 on the right, so I want to move the 3 over x plus 1 on over. So I'm going to subtract the entire thing. So I'm going to get 5 over x minus 3 minus 3 over x plus 1 is greater than 0. Now this, I know exactly what the inequality is doing because it doesn't matter when I add or subtract, my inequality is not going to change. That was his whole argument with me, and I've kind of gone with it since he has a PhD and I just have my BS. All right, so now with this, I'm going to go ahead and solve this. So I need to get a common denominator. So the best thing to do is just multiply my denominator. So I'm going to have x minus 3, x plus 1. And then I'm going to multiply up like this. I'm going to have 5 times x plus 1 minus, and I'm going to multiply up like this, 3 times x minus 3. And that's going to be greater than 0. From here, we're just going to simplify. I've got 5x plus 5 minus 3x plus 9. Be careful, negative 3 times negative 3 is a positive 9. Make sure you distribute it all over. And I'm not going to fix this. I'm going to leave it like this because the ultimate with this, we want to get it to factored form. So now we have x minus 3 and x plus 1. Now let's clean up the top. Don't forget our greater than 0. Clean up the top, and I've got 2x plus, that's 14, over x minus 3 and x plus 1. All right, greater than 0. Now at this point, go ahead and set everything. So we know that 2x plus 14 can equal 0. This means that x will equal, that's negative 14, so negative 7. We know that x minus 3 cannot equal 0 because it's in the denominator, so x cannot equal 3. And we know that x plus 1 cannot equal 0, therefore x cannot equal 1. Here are my critical values, negative 7, 3, and negative 1. So we put it on a number line to do our inequality test, put them in the correct order, negative 7, negative 1, and 3. Pick your numbers. Negative 10, negative 7, and negative 1. I'm going to pick negative 2. It's pretty easy to do math with. Negative 1 and 3, well, clearly 0's in there, so I'm picking 0. That's super easy to do math with. And then a number bigger than 3, I always like 10. And now what I'm going to do is I trust my algebra. I can go here, but you can always go back to any step. You can start, I would recommend you guys start with your original step if you don't trust your algebra. But I trust my algebra, so I'm going to come down here. And I want to put a negative in. So I'm going to put my negative 10 in. Once again, I'm looking for numbers that are greater than, but I'm going to just fill in positive or negatives and come back and evaluate. So let's see, I've got a negative 20 plus 14, so that's negative. A negative minus, that's negative, so that's going to make a positive, times another negative, so this is going to be a negative. I'll put negative 2 here. So negative 2 times 2 is 14, so that my top is positive, negative, negative. So that makes it positive. Because I have a positive, negative, negative. Put my 0 in here. I got a positive, a negative, and a positive. That makes this negative. And I put 10 in here. That's going to be positive, positive, and positive. That makes this positive. Once again, I challenge you to try to do it this way instead of just plugging the numbers in and crunching out the numbers. Use the concept to solve the problem, not just pure math. Throw the number in and solve it every time. Because it's much easier because the number is irrelevant. All that matters is the sign. Is it positive or negative? Because now what I'm looking for is, I'm looking for when this is greater than 0. The only time it's going to be greater than 0 is when it's positive. The only time it's going to be greater than 0 is when it's positive. You've got to love our bells. All right, and now because this doesn't have an equal to sign, I've got an open dot here. That's a horrible open dot. Open dot here, open dot here, open dot here. So I'm looking for it's positive. It is positive here, and then it's positive going this way. So my solution is going to be my parenthesis, -7 to -1. Jump over to 3 all the way up to infinity. And that's it. So the skills you learn in Algebra 2 by combining your rational functions, you're going to have to use that. And then once you get down, you're going to look at every place where it can equal or not equal 0. Those are your test values. Plug them in on a number line, do your inequality test, and then from there, just go back old school, write it on a number line, and then just write it out. Easy peasy. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.